like collaborated and wrote on enhancing the MLOps deployment process using GenAI. So let's deep dive into it. So this is our abstract, which feeds the paper examines the current state of MLOps and emphasizes the importance of developing ML and AI-powered applications. This study commences by defining MLOps and conducting a literature review to highlight critical studies in this area. It then delves into the current state of MLOps, providing examples of how major tech companies implement MLOps across their organizations. Additionally, the paper discusses the benefits of utilizing MLOps and addresses the deployment challenges in the current process. Furthermore, it proposes an innovative solution to improve existing practices. It presents a technical architecture system design, implementing this novel approach using GenAI to enhance and streamline the MLOps deployment process. Moving on, I think let's understand like what is MLOps. So MLOps or machine learning operations is a set of practices and tools designed to automate and streamline the end-to-end machine learning lifecycle, from model development to deployment and monitoring in production. MLOps focuses on improving collaboration between data scientists and operations team, ensuring that machine learning models are efficiently developed, tested, and maintained. Big tech uses MLOps to automate the ML deployment pipeline. Like just imagine the systems of like massive systems of, let's say, NVIDIA or Google or Meta. They have so many like ML algorithms running on their platforms every second of the day, right? In different geographies for their different products. And it would be like a massive hassle for them to maintain all of those. So, of course, like they have advanced on the MLOps practices, but our paper tries to go even further and see that, okay, how we can like optimize it even further using GenAI. So moving on, let's just like look at this state, of MLOps. The market size in 2024 currently is $3 billion. The industry is growing at a rapid pace, with AI becoming a strategic initiative for organizations globally. It is expected to reach $60 billion by 2033, right? And big tech will define the overall market, as in 71% of overall market share will be like held by big tech. And some prominent players in this space are Google, IBM, Amazon, Microsoft, and Databricks. I mean, of course, there are like some others coming up in terms of startups, but these are the prominent players, right? So we can see that like this industry is growing, this particular thing, right? And it will grow, like continue to grow until 2033. And we can also like see that it's approved from the Google Trends keyword search, that how in 2019 versus 2023, in just 4 years, the left side is calibrated in millions. The search term is MLOps, and it has like picked up like since like if you see this in 2022, like sometime in January, it started picking up, right? And right now it's like 100 million keyword searches for MLOps on Google Trends. It shows that the interest in this particular area of business is growing. And also it is like from all the different consultant companies or big tech, they have been trying to implement this or bring this into practice. So now let's just think and go through some of the benefits of MLOps, right? So basically, it builds trust by automating the deployment process through testing and validation. It helps organization maintain and scale several ML-based applications in production. Like I just gave the example of Google and Meta and similar big tech companies. MLOps helps organization better manage and maintain big data. It helps organization to deploy solutions faster in production. It helps teams and organizations be at the forefront of compliance law by automating tasks and better managing data and maintaining the laws in different regions. So there is something like basically, if let's say if someone is doing it manually, they might be looking at data, they might be handling like personal information. In a lot of like countries, they do not allow someone like individual to maintain that, right? So basically, MLOps helps these companies to maintain and to like and query through, run through this personal information wherein no particular individual has access to those data or they see those data, right? It's all handled by MLOps systems, right? Now let's just go into like MLOps life cycle, right? So basically, like what's the life cycle is, and so basically it all starts with data gathering and cleaning. And like this is the first step where raw data is collected from various sources. The data might be messy, incomplete, or contain errors. So it needs to be cleaned and processed. This step ensures the data is ready and suitable for training a machine learning model. Right? This is the first step. And the teams, they spend a lot of time in this particular step for data gathering and cleaning, because if the data is not properly gathered or cleaned, then all of the subsequent steps, they will not be able to get the results they expect to get. Then the second is like machine learning development. So data scientists, they in this step, they use the clean data to build and experiment with different data learning models. Like this involves selecting the right models or algorithms, then basically training the algorithms, passing through the data, and testing it, these models. And they again like spend a good amount of time over here because they need to ensure that they are selecting the right models for the right use cases. Now, once that is done, they move into continuous training, right? Basically, like because the thing is, now they have trained the data, but the user behavior, if you think about it, let's say take an example of Instagram. The user behavior is changing ever, right? The users are producing lots of data, and they are and as a company, they are releasing a lot of different features. So how those features interact with the user behavior, how those features interact with the platform, how does like different users interact with each other because of those new features. So like all of this, like they have to like continuously pass this data. So, like continuous training is important, right? Because once a model is developed, it may need to be updated regularly with new data, and that's what this particular step is. Then the next one is like model evaluation. So after training, the model is tested to see how well it performs on new unseen data, right? This step checks whether the model is accurate, reliable. It helps to identify any issues that need to be fixed before the model can be used in real-world scenarios. So model evaluation is something that each team does, right, on a regular basis. They keep on testing this, and based on this, they try to see, and they again go to the first, second step of like model development, like whether they need to like create new models or like pick up new algorithms or fine-tune the existing model. Once the model is evaluated, they go into the model validation step, in which this step is about like verifying that the model meets the required standards and criteria. It ensures that the model performs as expected under different conditions and is safe to deploy. This might include testing it on various data sets or checking for biases, right? Because this model validation is again a very important step to ensure that there's no biases on the data or basically the output that the algorithm is producing, because everything will be like automated once it's on the production environment. Then the next is model deployment. So once the model is trained, ready, validated, it like goes into the production environment. And then it's like the next step is prediction serving, which is the deployed model now starts making predictions on new and live data. This stage is where the model actively delivers value by providing insights, recommendations, or classifications based on incoming data. So this algorithms, once they are like in production environment, they need to provide some sort of like user value or business value to its users, which could be in terms of, let's say again, go back to the example of Instagram. When we go on Instagram, everybody's feed is different. Why? Because everybody's behavior is different. And based on those behaviors, this machine learning algorithm produces different feeds for individual users, right? And that's how our feeds are different. So even though let's say two users in the same location, maybe some sort of like but different liking, different usages, they will see totally different feeds. And this is what because of all of these different algorithms, right? And the last step is like continuous monitoring. Like someone has to monitor it to ensure that the algorithm is working as expected and is not producing results that's not unexpected. Because there's this platforms wherein this machine learning algorithms are deployed are being used by end users or business users. And if it produces results that are not desirable, it will be a massive loss to the company in terms of revenue, also in terms of brand image. So this is what MLOps lifecycle is. So when we look at like different tools and technologies, so I think they're like ton of it. I'm not going to go in individuals, but yeah, we wanted to like mention some of this, which are widely used across the industry. And then like we go into the challenges, right? Like what are the current challenges that we see this companies and the teams they face in the current MLOps process? The first one is model versioning and management. Basically, managing multiple versions of ML models and tracking changes over time can become complex during deployment. Just imagine like the example that I've been giving of Instagram. They have so many different like models that are deployed for each and each in, and like for each of the different features on Instagram for different geographies or different languages. Just managing their like versioning will become like it has becomes like massive challenge, right? The second is scalability and performance. Like ensuring deployed ML models can handle varying workloads and scale effectively is critical. Resource constraints such as limited memory or processing power can impact the performance and responsiveness of deployed models, especially in high demand scenarios. So we need to make sure that our models are scalable and they perform when they require to perform. So they are like peak times wherein a lot of users are using the platform. So if the model doesn't perform during that, I mean, it's a massive failure on the part of the team. Third is dependency management, right? ML models can often rely on complex dependencies, including libraries, frameworks, and managing these dependencies and ensuring compatibility across different environment can be difficult while deploying, right? We can totally understand that, right? Because if there's dependencies across different like the servers, different systems, so managing those can again become a huge challenge for the teams. Then the next one is data drift and model decay, right? ML models are trained on historical data, which may become outdated and no longer represent the current environment. Addressing data drift and model decay requires continuous monitoring. So basically, we need to make sure, like someone from the team needs to make sure that the data that the models are trained on are updated or refreshed from time to time, and not just the data, but even the algorithm, right? Maybe like there's a new version of the algorithm, or maybe the team has like built a new algorithm. So again, managing those, then uh, phasing out the old one, bringing in the new one. Again, this becomes like super challenging, right? And the last one is like monitoring and maintenance. Like once deployed, like I said, the models need to be maintained, they need to be monitored for the results or output or outcome, and also see that what's new. So these are like challenges in the current MLOps process. So what are we saying? Like, what are we proposing? So basically, Gen AI and MLOps. So basically, we tried a methodology where models can be packaged based on the size of the group, correlated workloads, and machine type, rather than manually trying to create them. By automating the packaging process with Gen AI, organizations can streamline deployment workloads, reduce manual intervention, and ensure that models are effectively deployed and maintained to handle multiple workloads and resource limitations. So what we are proposing here is, so currently in the current process, all of this, like the different ML models, they are also like packaged, but they are like done in the basis of like the process is super manual. And also it takes a lot of time and effort. And then there's like integration issues and then dependency constraints. But what we are saying is all of this can be trained on a specific like Gen AI model for the individual companies, wherein the Gen AI can understand what the ML model is doing for the company, and they can create these packages such that each of these packages will contain from one to anywhere to n number of this machine learning algorithms, and they can be deployed to the production environment such that the workload of like managing this packaging or creating these packages, then packaging it together, pushing it to production, which takes a substantial amount of time, and it's also like prone to human error, can be alleviated by using GenAI. So with this, right? So what are the different things that we can do with this? So like automated workload analysis. So GenAI can be used to do a lot of tasks in this paper, right? Authors we propose a new model to analyze MLOps workloads using advanced pattern recognition and data analysis techniques, analyzing workload size, complexity, and resource requirements. Right? So basically, Gen AI can be trained to understand like what kind of ML model it is, what kind of data they are like processing, what kind of analysis they are doing, and based on that, we can like try to package them together. The second is like contextual understanding. Like Gen AI understands the context of the workload, considering multiple factors like correlated workloads, machine types. It analyzes and structures how these factors influence the optimal packaging configuration for deployment. Like one of the basic feature for Gen AI is like contextual understanding of anything that we ask Gen AI to, right? Let's say even if we are using ChatGPT or Perplexity, they understand our intent. Similarly, in this one, what we are proposing is Gen AI will understand the context of each of these models, right? Not just take the technical configuration, but also the business configuration or business context and try to package it together. Then recommendation generation. So based on all of this, Gen AI will recommend the user or the team that, hey, what you can do in terms of like packaging some of the algorithms together so that it's easier on your hardware, which is like CPU, GPU, or memory, and also it helps and serves the interest of the business. Then continuous learning. Of course, like as these models are generated and they are deployed, GenAI will continue to read and understand like how the models are performing, which models works best together, which doesn't work best together, like how they can like package like in the future. And based on that, Gen AI like auto updates, and then or in the future, like the new the all the new algorithms they are packaged differently such that A, it reduces the cost for the businesses when they are running on production environment. B, it reduces the workload for the team. C, it reduces the human-based error. And fourth, it provides the best output possible. So based on this, we created this system design algorithm or system design, sorry, over here. I mean, it might not be very clear, but just to like give you a high level overview. So basically it starts with the identification of workload, right? The process begins when a new workload is introduced to the existing group. Then metric and the model collects essential data, including workload size, memory, and different things. And it comes up with all around recommendation that aligns with the tasks. Then which is like the next one is model evaluation or inference. So say then the model analyzes and collected data in detail and determines the optimal deployment process. The analysis considers various factors such as workload, available resources, and cost efficiency. Then it is prediction. The model analyzes several factors and parameters to predict the right grouping for the deployment pipeline. And then it comes with the recommendations, weighing like which algorithms or which models should be grouped together or packaged together to push it to production. And then the recommendations are presented to the tech team. The tech team can either choose by default whatever like the system is recommending them, or they can just choose to like move around some of the models with the best of their knowledge and expertise, and then finally the recommendation can be evaluated or can be pushed to production. So yeah, with this then basically the next one would be for decision making, which is the team selects the most suitable deployment option from the recommendations provided by the model from the dashboard. And this decision is based on careful consideration of all relevant factors. Like I said, either the team can choose whatever these Gen AI system is recommending them, or they can also provide their own inputs and do some changes. And then the next step is deployment, like post the deployment process is initiated according to the chosen option. This may involve deploying the model to an existing group or creating a new group. And the last on the list is monitoring and optimization. The system is continuously monitored to ensure optimal performance. And then the Gen AI, it learns, it sees like, how this recommendations based on the user changes or not so many changes when they are deployed, how they are working together, and what's the workload on the on our systems, right? Means CPU, GPU, RAM, and other things, and what's the cost, and all of those. It takes all of those data from the real environment and system, and based on that, it will update its recommendations because it's also continuously learning. So yeah, so this is what we are proposing as a team. Uh, yeah, so thank you so much.